I'm Casey Cole, CEO at London-based technology scale-up Guru Systems. Today I'm going to talk to you about our experience of building a mobile and web app to digitalize the process of commissioning a heat network. Before we start, I'd like to introduce you to Guru. We've got 10 years of experience developing intelligent technology to make energy systems more transparent, lower cost, and lower carbon. There are around 50 of us in the team, and so far we've delivered more than 45,000 devices across residential heat networks in the United Kingdom. We capture data from these heat networks, and we have a number of software solutions that help heat network developers and operators meet their regulatory requirements and manage the performance of their networks. We process more than 1 billion measurements from our deployed hardware every month, but it's what we do with that data where the story gets interesting. You can see the names of our technology solutions across the bottom here, but today I'm here to talk about Guru Verify, our mobile and web app for quicker and more cost-effective heat network commissioning. Correct commissioning can significantly reduce heat losses. When I talk about heat network commissioning, I'm referring to the process of ensuring that the heat network is operating as detailed in the design before any residents move into the building and the heat network enters the operation stage. Our experience at Guru is that getting it right at commissioning stage can make all the difference when it comes to the efficiency of the heat network in operation. The results of a project that we did in collaboration with the UK government showed that proper commissioning alone can reduce heat losses on networks by nearly 70%. So that's actually what we're looking at here with these two charts. This shows you a before and after on a project we ran with heat network consultancy Fairheat. We worked with several heat networks in the UK that hadn't been properly commissioned and weren't performing well, often at efficiencies of around 30 or 40% overall, relative to design intent of well over 80%. The project saw a number of interventions, and using the data captured and then analyzed by Guru Systems Technology, we showed that significant heat loss reductions could be made if commissioning was done properly. In an effort to drive better heat network performance 2 years ago, the industry in the UK came together to publish an updated version of our heat network code of practice. The new version is called CP1 2020, CP meaning code of practice. CP1 isn't regulation yet. Instead, it's a good and best practice guide for building heat networks. It's comprehensive with lots of recommended minimum standards and best practice points. But one particular area of the code of practice that's seen significant change is around how heat networks should be commissioned. CP1 2020 introduces acceptance testing. Heat network consultancy Fairheat describe acceptance testing as rigorous testing to verify dwelling performance by ensuring the installation, commissioning, and operation are as per the design and performance specification. So it's making sure that the system, once commissioned, is operating as intended. In CP1, minimum standards now require independent testing on a sample of dwellings, and best practice is to test every dwelling connected to the heat network at commissioning time. At Guru, we advocate acceptance testing on 100% of dwellings because, in our experience, it only takes one poorly performing dwelling or HIU, heat interface unit, in that dwelling to throw off the performance of a heat network. When performing well in standby mode, an HIU might see 4 liters of water pass through every hour. But when the settings are wrong or it's poorly commissioned, this could be as high as 400 or 500 liters an hour. So if you've got 100 HIUs in a block, 99 of them are performing well, but one is badly misbehaving. The water flowing through that misbehaving HIU could be more than all of the other HIUs combined. And this means that back at the energy center or at the boundary of the block, you're going to have much higher return temperatures and therefore higher heat loss, higher cost of delivered heat, higher carbon emissions. Maybe your boiler stops condensing or your heat pump coefficient of performance drops as a result. So the consequences are big. The challenge we have is that there's limited experience to deliver acceptance testing in the UK, which makes it expensive, or can do. There's also a significant skills gap that we need to overcome if acceptance testing is going to be carried out on all UK heat networks. Historically, to do heat network commissioning well, you needed very well-trained engineers, and the process was manual. These are just some of the photos the Guru Systems design team took when we were researching the problem. While the process is supposed to deliver a well-commissioned heat network, in reality, we heard it was more common for an engineer on site to sit with their coffee or a cup of tea and sign commissioning certificates without even visiting the dwelling. And anecdotally, we had stories from clients of their contractor or subcontractor handing them commissioning certificates with the coffee mug rings still visible alongside the signature of the engineer on those commissioning certificates. What this means is, in practice, is that mistakes are missed. We've been to poorly commissioned networks where we found incorrect HIU set points, missing insulation, unbalanced heating systems, and even things like radiators installed back to front. Now that acceptance testing is required under CP1, we needed to find a way to ensure that the scenes from these images aren't repeated as our industry grows. Our solution was to develop Guru Verify. Verify is a mobile and web app to deliver quicker and more cost-effective acceptance testing. We developed it in partnership with Fairheat, the consultancy that we did that 2016 study with, as well as complying with CP1 2020. It allows heat network developers to benchmark for future maintenance and efficiency improvements and hold their supply chain to account. Crucially, it's been designed for all levels of expertise, so it makes it possible for anyone to test a network, even brand new apprentices, because the process is baked into the app. You can see photos here of the engineers using the app to go through the process step by step, and then it results as they go. One of the real values of the product is the web platform. The web platform allows you to define testing criteria and check dwelling status remotely. It's possible to track progress across the entire site online, and you can access test results and photographic evidence for as long as you need. Here you can see what a site dashboard looks like. This can be used by a team lead, for example, to check how far through testing the team is. From there, you can look at an overview of each dwelling, seeing at a glance whether each dwelling has passed or failed each stage of the test and whether any retests are required. If you click on a dwelling, an overview of the results for each section of the test are shown. These can be expanded to check individual values. And evidence relating to any visual inspection can be accessed, so you can see the images that were taken. These results are stored on the cloud and can be accessed by different stakeholders at different points, for example, within a warranty period, or to check back against when recommissioning a network years down the line. Before we finish up, I want to take you through 3 case studies of sites where Guru Verify has been used and show the real impact it's having on heat network performance. The first case study is from a site with 337 homes in London. We've taken a snapshot of the data we see on our performance management software, Guru Pinpoint, now that residents have moved in. The graph here is from Pinpoint and shows a well-performing dwelling. Flow rate in light blue is low when the HIU is in standby mode. But when the heat is required, when the heating is turned on in the morning, for example, then flow rate rises. The flow temperature in dark blue hits around 65, but return temps in green are low, around 30 degrees, showing that heat energy is being extracted from the network as it should be. When the heating is turned off, flow rate drops right back down again. Another site, this time we're looking at data from the energy center of another network in London. Data from the energy center shows that despite varying load across the week, that's the yellow line, flow temperatures in blue and return temperatures in green sit steadily at around 60 degrees and 30 degrees respectively. The graph here shows a day in the life of one dwelling on the Stone Studios network. Although it might look chaotic, this is what a well-performing dwelling looks like. When heat is demanded, flow rate in light blue increases, and the delta T, the difference between the flow temperature in dark blue and the return temperature in green, is very large. At a given flow temperature, the larger the delta T, the more heat energy is being extracted from the heat network, and the cooler the water returning to the energy center is. In conclusion, when heat networks are commissioned correctly, they can perform really well, helping to keep costs for operators and customers low. To ensure commissioning is successful, digital tools like Guru Verify are a must if we're to support our growing industry and address the skills gap in a sustainable way. Before I finish, I want to reinforce the point I made about digital tools. Guru Verify is just one of the products we make to accelerate decarbonization of heat. The graphs showing heat network performance come from our software platform, Guru Pinpoint. Pinpoint uses machine learning algorithms to help operators identify and resolve heat network performance issues. I also mentioned that we developed Guru Verify in partnership with Fairheat. We think that collaboration is going to be key if we're going to solve our decarbonization challenges as quickly as possible. As well as working with Fairheat, we've collaborated with Kalefi Group to create a hardware and software solution that allows you to read and control electronic HIUs remotely. We're really excited for the potential of this solution used in conjunction with Verify to make the commissioning process even faster and to ensure networks stay performing well over time. On that note, I'd like to end my presentation here. Thanks for listening, and thank you to the Smart Energy Systems International Conference for organizing the event. Please do get in touch if you have any questions or if you'd like to collaborate with us. Thanks.